Okay, we're at the review guide for Math 086, and this is for students that need to review. All right, I always think everyone should review things, and you determine if you need to review by looking at the document. So Math 086 is the first course we use at Essex County College to introduce students to algebra. And it's called Introductory Algebra. It's Math 086. We cover topics in it, and certainly you can read through this, you'll know what topics are being covered. I do want to point out that calculators are not permitted in this course. All right, what I'm going to do is I'll go through the document one problem at a time. This is a review problem set. And our students that show proficiency in Math 086 should be able to do these problems with little to no issue. All right, so let's take a look. This is the signed integer problem, and we're adding those terms together. How many terms are there? 1, 2, 3, 4, 5 terms. All right. Now, certainly, if I were adding this together, I think I would do it quickly, but certainly I'm not saying I couldn't make a mistake with it. So what I want to do is just move left to right, and as I move left to right, the first two terms I see is 2 plus or minus 5, and that would be minus 3. And then I'm going to write the following terms down. Now, minus and minus 3 is plus 3. I'm going to keep moving left to right. Now, minus 3 minus 7 is minus 10. And I'm going to keep moving left to right. Now, minus 10 plus 6 is minus 4. And minus 4 plus 3 is minus 1. All right, we provide answers for you. They're in boxes. This one is a decimal arithmetic. And let me write this down that way most students would do it. They would line the decimal up and do the subtraction. I'll just add a 0 there. Most students, when doing the problem, again, your options are your options. You do what you can to do the subtraction. But I'm going to say 3 can't be taken from 0, so I'm going to borrow it from this, and this becomes 10. All right, so 3 from 10 is 7. Now, I can't take 8 from 0, so I'm going to borrow from the 4. That becomes a 3. This becomes a 10 now. 8 from 10 is 2. I can't take 6 from 3, so I borrow from the 5. That becomes 13. That would be 7. Decimal point. And 2 from 4 is 2. So the answer would be 2.727. All right, this one's a fraction problem. And for fractions, what I recommend is first get an LCD. We can do that by inspection. And looking at it, looks like 12. And I'm going to write each fraction so it has a denominator of 12. The first fraction is fine. The second fraction does not have a 12's denominator. So I need to multiply the 3 by 4 to get 12. If you multiply the bottom by 4, you multiply the top by 4. Plus 1/4. Well, what times 4 gives you 12? 3. Remember, if you multiply the bottom by 3, you multiply the top by 3. The main reason here is these are builders, and builders are always numerically 1. Let's do the arithmetic now. What do you get? 5/12 plus 8/12 plus 3/12. They're all 12ths. I'm just adding your numerators now. 5 plus 8 plus 3. And if you did that, what do you get? Well, going left to right, 5 plus 8 is going to be, let's see, 13. And 13 plus 3 is 16/12. I'm going to reduce that. It's in your interest to reduce that. I'm going to divide by 4. When you divide the top by 4, you get 4, and the bottom by 4, you get 3. So 4/3. You should also be aware that 4/3 can be written as a mixed number. 3 goes into 4 one time with the remainder of 1, so 1 1/3. Right? We don't like mixed numbers in algebra, but in the English language, we wouldn't say 4/3. We would say 1 1/3. All right? We'll go to the next question. These are mixed numbers. And again, mixed numbers, what I would claim mixed numbers, you probably should write them as improper fractions. So let me go through that with you. And the algorithm that most grade school students are taught is they do a quick way of adding that together. I want to point out, though, that grade school algorithm I told you, let me write this down for you, 3 plus 2/5. That's how that's read, by the way, 3 and 2/5. Common denominator would be 5. So I'll put 3 over 1, 5 over 5, plus, this is not what you were told to do in grade school, by the way. This would be 15/5 plus 2/5 equals 17/5. Oops. So I want to point out what you were told to do in grade school. You were told to take the 5, multiply it by the 3, that's 15, and add the 2 on it, and you get 17/5. There's nothing wrong with that. It's a shortcut. Next one's going to be 10 times 1 is 10, and 10 plus 7 is 17/10. The next thing I'm going to do is common denominator. and that's a 10. So the LCD is 10. 17/5 times 2 over 2 minus 17/10. What do you get here? 34/10 minus 17/10. And lo and behold, you get 17/10. I kind of like that number, but again, in the English language, we would say 17/10. We would say 1 and 7/10. All right, these answers are listed over here for you. This is a division problem. I'm going to write a little differently. So it's minus 4/9 times 27/8. Again, let me write that down for you. A over B divided by C over D is equivalent to A over B times D over C. All right? So let's take a look at that. And I'm going to kind of reduce it. And, when I do that, I'm going to put a slash this. 9 goes into 9 once. It goes into 27 3 times. 4 goes into 4 once. That's what that slash means. And 4 goes into 8 2 times. And what are you left off with? Well, let's see. You left off with a minus sign. On top, you get 1 times 1 times 3, which is 3. On bottom, you get 1 times 1 times 2, which is 2. That's a fine-looking answer. If you want to write a mixed number down, well, 2 goes into 3 one time with the remainder of 1. So it's minus 1.5. Both answers are listed for you. All right, this one's a multiplication problem. Let me write down for you minus 2 27s times 9/8. Well, I'm going to do my reduction. What would I do? 9 goes into 9 once, goes into 27 3 times. 2 goes into 2 once, and it goes into 8 4 times. So what are you left off with? Well, certainly a minus sign. On top, you just get 1, because 1 times 1, that's what those slashes mean. On bottom, what do you get? 3 times 4 is 12. So you get minus 1/12. All right, this is a decimal division problem, and let me write that down for you. Now, granted, some people may look at my work and say, oh, your work is different than what you're doing at the whiteboard. You're right, sometimes it is. I want you to say there's variations of what people can do. But I'm going to do what you did in grade school. 2.3 divide in 1.334. What did your teacher tell you to do? Well, move the decimal place over. Really, what are they doing? They're multiplying by 10. The top number by 10, the bottom number by 10. What do they get? 23. Whoops. And what do you get over here? 13.34. The next thing your teacher told you to put the decimal point up here. And then start to do the division, but don't look at the decimal point anymore. Just look at the digits. 23 doesn't go into 13, but it does go into 133. And how many times? I'm going to say about 5 times. So 5 times 3 is 15. Carry the 1. And 5 times 2 is 10, plus 1 is 11. That looks pretty good. And then what do? You subtract. Most students do not write the subtraction symbol down, and nor would I. But you could if you want. It is a subtraction process. What do you get over there? Well, it's 133 minus 15, and that's going to be what? 18, right? Let me see. Yeah, 18. Then what do you get? A 4 over here. Then the question comes is, what times 23 would give you close to 184? I'm going to maybe say around 8. 8 times 3 is 24. 8 times 2 is 16. Oh, wow, look at that. No remainder. So what do I get? I get the answer, which is 0.58. All right? Again, there's work over here that might look different to you, but it's really equivalent work. It's really equivalent work. All right, this one is a exponent problem, and what does it do? Take the number minus 2 and write it down 3 times. Let me go left to right, doing pairs. Minus 2 times minus 2 is 4, and 4 times minus 2 is minus 8. Now again, some students question, do I need to write that down? No, you need to get the correct answer. It's a pretty simple arithmetic problem, but writing it down can't hurt. Right? This one over here is a negative exponent. What does this mean? 1 over 3 squared. What do you get now? 1/9. All right, let's do the next one. This is an order of operations. What am I going to do? Grouping symbols first. Well, there's a group 3 minus 5. It's in parentheses. That's a grouping symbol, and there's 2 members in that group. That would give me minus 2. Then I have minus 12 divided by 2. What's the next thing? Multiplications and divisions, left to right. This would give me minus 4. Minus, 12 divided by 2 is 6. What do you go there? Minus 4 minus 6, which is minus 10. All right, let's keep going. This is a complex fraction, right? The way we do a complex fraction is we multiply by what's called a minor LCD. Well, there's a bunch of fractions here. These are smaller fractions. I want to point out what I mean by that. This is a minor fraction, minor fraction, minor fraction, minor fraction. The major fraction is this long bar over here. So I'm looking at the minor fractions, 7. I'm looking at the denominator, 7, 14, 27. So I'm going to say the minor LCD is 28. Let me write that down for you. The minor LCD is 28. Our recommendation is to multiply the top by 28 and the bottom by 28. This is what's known as the builder. 28 divided by 28 is the number 1. What do you get over here? Well, let's go the distribution problem, distributive property. So it's going to be 2 7s times 28 minus 3 14ths times 28. If you can do that in your head, please do so. 5 28ths times 28 times 28. 1 7th times 28. All right, so what I'm going to do is I'm going to start to reduce. 7 goes into 7 one time, and it goes into 28 4 times. 14 goes into 14 once, it goes into 28 2 times. 28 goes into 28 once, goes into once. 7 goes into 7 once, into 28 4 times. What am I going to do? The arithmetic. So first term, this guy over here, is 8. Minus second term, this term. What's that going to be? 6. What do you get over here? Well, this term over here is 5 times 1, which is 5. Plus, what do you get? 4 times 1, which is 4. What do you get there? 8 minus 6 is 2. 5 plus 4 is 9. 2 ninths. Answer's right over here. All right, let's just one over here. This says convert to a mixed number. Well, some students do this. I'll write this down for you. They actually do a long division. And what do you get over there? 7. This would give you 28. And if you did subtraction here, what do you get? 3. So what's the answer going to be? It's going to be 7. The remainder is 3. So I'd write this way, 3 quarters. Now, that's the way I would write it. I would write 7 and 3 quarters. In the United States, though, we shorten it up. We just simply say 7 and 3 quarters. And that's often confused because people look at that and say that's a multiplication problem. It's not a multiplication. It's 7 and 3 quarters. We write mixed numbers this way over here. All right? I actually prefer this way. All right? You decide. All right, let's keep going. Convert 5/8 to a decimal. Again, there's many ways to do it, including recognizing it. But I'm going to do it by long division. And that's going to be 5 into, I'm sorry, I misread. It's 8 into 5. I would recommend putting a decimal point here. Now, 8 doesn't go into 5, but it goes into 50. How many times? 6 times. That gives you 48. Subtract, you get 2. Add another place. 8 goes into 22 times. That's 16. Subtract, add another place. You can do this until you figure out what it's going to be. And 8 goes into 45 times. So what do I get? I get 0.625. And that answer's right over there. Convert this to a percent. There's many ways to do it. Let me write this down for you. Probably the simplest way is just to simply multiply by 100%. What's 100%? It's 100 parts out of 100, which is equivalent to number 1. So it's not changing the number. Well, what do I notice now? I'm looking at it. 25 goes into 25 once, and it goes into 104 times. So what are you left off with? Well, 9 times 4 is 36%. That's there. Let's do number 15. This says convert into an improper fraction. Well, again, this is 5 plus 3 7s. If I were to, do my arithmetic, I would write down 7 over 7 plus 3 7s. What do you get there? 35 7s plus 3 7s, which is 38 7s. And that's one way to do it. Another way to do it, I'll just remind you what you did in grade school. Your teachers told you 7 times 5, which is 35, and add 3 to it. That's right over here, which would give you 38 7s, all right? You decide how you're going to do problems, though. Don't think there's only one way to do a problem, all right? Hopefully you have some understanding what you're doing, though. This one says convert to a decimal. Well, for me to do that, I got to be honest with you. What I got to do first is I've got to convert that 3/8 to a decimal. So 8 into 3. I'll put this over here. 8 times what would give you 30? It doesn't go into 3, by the way. It goes into 30. Let's see. That's 3 times, right? And 3 times 8 is 24. And then when you get 6, I'm going to add something. And what would you get there? I'm going to say 7. That's going to be what? 56, right? And then you get 4, 0. And that didn't add a place over here. What do you get over here? That's 5. So what's his number over here? It's 4.375. Good job. All right, let's keep going. Let me see if I answered that question now. Yeah. Okay, next one up, convert to a percent. Well, it's a mixed number, and I'm just going to write it as an improper fraction. And I'm going to do it the quick way. 3 times 5 is 15. 15 plus 2 is 17/5. Now, if I want to convert that to a percent, all I have to do is multiply it by 100%. Remember, 100% is just the number 1. What happens over here? A very nice reduction. 5 goes into 5 once, and it goes into 100 20 times. Now, what do you get over there? You would get 340%. All right. This one says convert into a fraction. Fairly easy to do. This is 4 over 100. That's fine. That is a fraction, by the way, but it says you should reduce it. Let's go through the reduction process. The first thing I would probably do is just simply divide by 2. And what are you going to get over there? Well, you get 50. If I divide the bottom by 2, you get 50. On top, you get 227. All right? So I'm going to say, that's not a bad-looking number. And I don't think I can go any further than that. For example, you're looking at 50. The only factors of 50, let me write this down for you, 2, but the top doesn't have a factor of 50, and 25 and 5 and 5. So the top has none of those factors, so I'm not going to go there. So I'm going to say I got my reduced form. It's right over here. Whoops. I got my reduced form, and I see that here. But they also want me to write the final answer. Oh, no, that's okay. They did write it as a mixed number, by the way. I want to point out that's okay to do. I don't recommend it, though. And what's it going to be? Well, let me write it down for you. It's 4 and, because 50 goes into 204 times, 27/50. All right, and that's right over there. All right, convert this to a mixed number and reduce your final answer to lowest terms. So let me write this down for you. And a mixed number would be 3 plus 0.124. All right, that's a mixed number, by the way. I got a whole number and I got a fraction. But, I don't think that's what they meant for me to do. They meant me to write it as a mixed number, like, 3 and some fraction. Well, 124 over 1,000. I'm going to keep rewriting this. 3. I'm going to reduce it now. And I'm looking at it. 124. I'm going to divide by, let's see, I guess I could divide by 2. That's 62, right? Over 500. And I can divide by 2 again. And what do you get? 31 over 250. So what's the next mixed number? It's 3 and 31 over 250. And did they say the mixed number? And you reduce it, and we did that. That's the answer they have listed over there. This one says convert this to a percent. Couldn't be any easier. Take the number 1.8 and multiply it by 100%. 100% again is the number 1. What do you have there? 180%. 180%. All right, convert 6% to a fraction. Well, that's pretty easy too. 6% actually means 6 parts per 100. I'm going to reduce that. What's the reduction of that? That would be, let's see, 3/50. All right, convert to a fraction, reduce final answer to lowest terms. So 3/50. All right, this one over here says convert 132% to a mixed number. Well, first thing I do is write a fraction down. That's 132 over 100. Now, if I were to write that as a mixed number, 100 goes in 132 100 times. One time. It goes in once with a remainder of 32 over 100. Let me reduce that. 32 over 100 is going to be 16 over 50. And I can further reduce that to 8/25. So the mixed number is 1 and 8/25. Again, answers are provided for a reason. Yeah, check them. Convert 9% to a decimal. Well, 9% means 9 parts per 100, and the decimal form that is 0.09. Okay? This one's an evaluation problem, and I'm looking at it, and I want to evaluate it. And what I'd recommend is you parenthesize the variable. So 3, what's x? X is minus 2, and what's the y? The y is minus 4. Now I got to do the order of operations. So multiplication done first. What do you get? Minus 6, and 2 times minus 4 is minus 8. What do you get? Minus 6 plus 8, which is going to be the number 2. Go to 25. This is another valuation problem. Again, my recommendation is parenthesize the variable and plug in the value of the variable, and then do your arithmetic. Minus 1. Well, minus 1 squared is 1. And then I'm looking at the next thing. It's going to be minus 3, but minus 3 is plus 3, and then minus 5. Going left to right, 1 plus 3 is 4. 4 minus 5 is minus 1. Again, I know this is going fast for some students. We're trying to encourage not to go fast, but to do the work on your own. And watching somebody else work is never enjoyable, but you might have to learn what someone else is doing before you try it yourself. So what do you get over here? It says evaluate A times B. So I'll write this down in parentheses, A times B. I'm parenthesizing the variables. And what do you get? 3.58. And then you get minus 1.026. Well, I do know the results are negative, but now I'm going to do my longhand multiplication. So 3.58, and then I got this 1.026. So what you did in grade school, it's not a bad way of doing it, by the way. You kind of ignored the decimal, and you did a distribution. And, 4 times 6 is 24. I'm retaining the 2 in my head then. 2 times 4 is 8. 8 times plus 2 is 10. 4 times 0 is 0, but I had a 1 carry, so I get 1 there. Then I get 4. All right, let me do the 5 now. And that's in the second place. 5 times 6 is 30. I'm carrying the 3. 5 times 2 is 10. Plus the 3 is 13. I'm carrying the 1. And mistakes can happen, by the way. 5 times 0 is 0, and I got the 1 there. And then I get a 5. All right, let me keep going. 0, 0. 3 times 6 is 18. I'm carrying the 1. 6, 7. 0, and 3. Wow, a lot of work. 4, 2, let's see, 12. I think I made a mistake because when I'm looking at my answer, did I write the right number down? Oh, I see it now. I wrote down 3.54. I have to correct myself because that's not right. I mean, someone says, oh, you're doing your work. Why don't you just get credit for the work you're putting down? That's not the question they asked. They asked a different question. I got to go through that again. So what's going to be, and sorry about that, it's 1.026, and I'm multiplying by 3.58. Sorry about that. It happens sometimes, and someone said, how'd you recognize that? Well, I looked at my answer key, and I noticed that my numbers were just not even close to those numbers. 8 times 6, that's 48. I'll do the carry this time. 8 times 2 is 16. 16 plus 4 is 20, right? I'll do the carry this time. 8 times 0 is 0, but I got a 2 there, and then an 8. I'm going to get my eraser out, and I'm going to erase those carries for you. Let me do the next one. And 5 times 6 is 30. 5 times 2 is 10. I got the 3 there, so that's 13. 5 times 0 is 0, but I got the 1 there. And 5 times 1 is 5. All right, and my eraser out can get rid of the carries. 0, 0. Let's see, 3 times 6 is 18. 3 times 2 is 6, 7. 0, and 3. 8, 0. 13, I'll do a carry. 17, I'll do the carry. 6 and 3. Count the places now, right? How many places you got? Well, I got 3 here and 2 there. That's 5, right? So let's see. 1, 2, 3, 4, 5. So what do you get? You get this number over here. Minus 3 point, we'll look at the key later, 67308. And I got to be honest, most people don't enjoy multiplication, but you should be able to do simple multiplications. Mistakes happen, though. Did we get the right answer? Sure did. All right, let's do 27. We'll take a break soon, don't worry. I'll write this down, and I'm going to kind of write it down without doing a bunch of parentheses over here. What's C, 2/3? Plus the D, which is 1/4. And then you get 2 times C. I'll use parentheses now. That's 2/3. And then the D is 1/4. I got to be honest with you, for a lot of students, just the act of writing it down might be helpful, but it may prove to be too difficult to do, but I don't think it's that bad to do. So what I want to do is I want to go through the arithmetic with you. And what do I notice immediately about this? I notice a 2 cancels a factor of 2 here, and then a 2 cancels a factor of 2 here. So if I were looking at that, I'm going to write that down for you, by the way. On the bottom, what would I be left with? Well, on top, I still get, sorry about that. Let me go back to black ink. On the top, I get 2/3 plus 1/4. And I'm just concentrating on the bottom now. What do I get? I get 1/3. Now, what I'm going to do is I'm going to multiply top and bottom by 12. That's the minor LCD. And what do you get on bottom? You get a 4. Fairly simple. It's 1/3 of 12 is 4. And on top, well, let's see. 3 goes into 12 4 times, and 4 times 2 is 8. 4 goes into 12 3 times, and 3 times 1 is 3. So what are you going to get over here? 11 quarters. If you want to write 11 quarters as a mixed number, we're not promoting it, by the way, but a lot of students want to do that. 4 goes into 11 2 times with remainder of 3. So it'll be 3 quarters. So 2 3/4 also an acceptable answer. All right, these are simplification problems, but we'll take a break soon, by the way. When I do this over here, we're looking for like terms. So I'm looking for squares now. Are there any other squares? I see one over there. So just doing that initially, what are you going to get? Well, minus 4t squared plus t squared is minus 3t squared. What are we doing? We're adding their numerical coefficients. I'm going to go to t's now. And what do I see? 3t and 5t, which would give me 8t. Lo and behold, we have last minus 6 minus 1, which is minus 7. Let's look at the answer. Minus 3t squared, 8t, minus 7. I'm going to take a break now. And I want to recommend when you're studying, you should also take some breaks. Not long breaks, by the way, but a break and come back to it. You should be putting a certain amount of time and effort into your studies. Thank you for paying attention.